To multiply these two roots together, the first thing I notice is that they're both square roots, meaning the index is the same. Even though there's no index, the index is a 2 on both of these. So I can actually multiply these together. So there's two routes to multiply these. You can simplify each root first because 20 has pairs and so does 8. Or you can multiply them together and then simplify. So I'm going to choose to multiply these together and then simplify. So when we're multiplying, the first thing I'm going to look at is the outside numbers. We're going to be multiplying those together. So negative 2 times 5 is negative 10. And next we're going to be multiplying the roots together. So to multiply two roots, all we have to do is multiply the inside numbers, called the radicands. So 20 times 8 is 160, and then k times k to the third is k to the fourth power. So from here, we do have to continue to simplify. I know that 160 has some pairs, so we can simplify the square root of 160, and k to the fourth is also a perfect square, so that can be simplified as well. So 160, if we make a factor tree, that would be 16 times 10. 16 splits as 4 and 4. 10 splits as 5 and 2. Those are prime, so I could circle. And then these 4s would split as 2 and 2. So these are the prime factors of 160. So what I'm going to do is rewrite my square root, except I'm going to extend the square root symbol. So instead of 160, I'm going to be writing the prime factors. So I have 2 to the 5th, and then times 5. So this multiplies as 160. And then k to the fourth, I could expand by multiplying k 4 times. So from here, we're going to be looking at pairs because our index is a 2. So I have a pair of 2s and another pair of 2s, and I have 2 pairs of k's. So those are perfect squares, so we could bring those to the outside. And anytime we bring a number or a variable to the outside, we're going to be multiplying it by what's already there, which is a negative 10. So two ways you could think of what's going to go on the outside with these two pairs here. You could actually multiply all 4 numbers together. So 2 to the fourth, or 2 times 2 times 2 times 2 is 16, and then the square root of 16 is 4, right? So 4 is going to go on the outside. Another way to think of it is you have a pair of 2s, which makes a perfect square, 4, right? And the square root of 4 is 2. And then you have another pair of 2s, which makes a perfect square because the square root of 4 is 2. And again, we're multiplying those together, so you get the same answer. You're bringing a 4 to the outside. And then we have a pair of k's. So k to the second power, if you take the square root of that, you just get k. And then again, another pair of k's. If you take k to the second power and take the square root of that, you just get k. So you're going to have k to the second on the outside. So on the outside, I need to multiply 4k to the second times the negative 10. So that's negative 40k to the second. And what is left inside? Well, on the inside, we're left with a 5 times 2, which is 10. So this would be my final simplified root.